Okay, so this is where the math is going to kick in when we start talking about vector addition, because vectors represent real-life forces and directions and velocities and all that sort of stuff, and so we want to start asking questions about them. What happens when you take two forces and add them together? What's the result? So we're going to do vector addition two ways this year. We're going to start by doing geometric vectors using the diagrams and trigonometry to solve them, and then later on, once we have a firm grasp of how these work, we're going to take the diagrams away and do it algebraically, writing vectors as ordered pairs instead of doing it in using diagrams and trig. That will be the next unit. So this unit is focusing on geometric vectors. So here is our first question. So I've given you an actual picture describing two vectors. The first vector we're going to call vector A. And it's right here at 10 kilometers an hour, 10 newtons, 10 whatever. Over here is vector B. And it's 15 whatevers, 15 newtons, 15 kilometers an hour, whatever. All you know is that the angle between them is 60 degrees. Not where they live in space or anything like that, just that they are 60 degrees apart. This vector diagram could have been drawn like this, have your 10 like that, and your 15 like that, and call this 60 degrees. But we just established that it looks like this. All you know is the angle between them. Either way, you're going to get an answer, and the answer is going to be relative to the original question. Okay, so what I'd like us to do is try and find a new vector which is described as C, and it is found by taking A plus B, vector A plus vector B. To add them, we have a special process of adding vectors. To add vectors, you take the tail of B and put it onto the tip of A. So take the tail of B and put it on the tip of A. So I'm going to try and recreate this in a vector diagram. So you see that this is the actual diagram, and we'll replicate this using a vector diagram to do the math. They're two very, very different things. So if I want to add A plus B, I'm going to just clone A here, so I have a vector just like it, and I'll move it down here. And you'll see that this is vector A. It starts here, finishes here, and it travels along that path, AB. If I'm going to add vector B, consider like a little road map. I started here, and I finished at the end at the arrow. Now I'm going to continue on and add B. So B continues on where A left off. Just move it over so the tail is right at the tip of A. And here now, it's like a road map. If we're adding A plus B, we went along A and then continued up and added B. Now, we're going to describe C as the resultant in this addition. C is a single vector that describes the beginning to the end. So this vector here is defined from here, and we ended up traveling through A plus B and ending up at that point there. And this new vector is C, and it is the resultant of A plus B. So now the trick is trying to find out how long vector C is. And this is where we're going to use our trigonometry. It's our grade 10 trigonometry. We'll use all that information. First though, let's label some of the sides that we know. A from the question is 10 units long. B is 15. The angle between them is 60, but you'll notice that 60 isn't in my picture. But what I can do is sort of extend this on and create the angle that's in the picture. This 60 here can be duplicated right there. You'll notice it's the same stuff. This is along A, and this is along B. And there's along A and along B. That's 60 degrees. Well, of course, if that's 60 degrees, the angle in between it, or inside, excuse me, is 180 minus 60, so 120 degrees. This picture, remember, is called the vector diagram. So, we now have a triangle. We know a side, that's another side, and its interior, the angle between those. And so we can use the properties of trigonometry to figure out what C is. Most commonly, we will be using the cosine law. We can't use SOHCAHTOA because we don't have a right angle, but we can use the cosine law. So let's remind ourselves of the cosine law. In this case, we're solving for C. So we say C, vector C squared. And you'll notice I'm only looking at the magnitude right now, so I'm going to put the vector symbols, the absolute value symbols around C. This is just to ensure that I know that I'm looking at just the vector's magnitude. So C squared equals the magnitude of A squared plus the magnitude of B squared minus 2 times A times B cos the angle between them. And we just figured out that the angle between them is 120 degrees. We can fill in some numbers now. A squared is 10 squared plus 15 squared minus 2 times 10 times 15 cos 120. The rest is an exercise on your calculator. You'll be doing several cosine laws, so make sure you're good at these. Some of you may want to work backwards. Punch in the cos 120. Make sure you're in degrees. Punch that in, times 15, times 10, times negative 2. Get an answer. Add it to 15 squared. Get an answer. Add it to 10 squared. And then don't forget at the end to take the square root. But after some work, you should end up with 21.8 units. I'll ask the teacher to pause the video so that you can double check that you get 21.8. And do help each other to make sure you get 21.8. Okay, so that tells us that magnitude C is 21.8 units long. But remember, the question asks you to find vector C, which means I have to describe an angle as well. So there's lots of ways to describe the angle, but what I like to do is refer the angle back to the beginning of the vector. You'll see the vector starts here and then goes off. Well, it's important to know where you're aiming the vector at the beginning. Some textbooks will ask you to describe this angle, but to me that doesn't make sense to talk about the end of the vector. To me, I don't want to know about direction over there. I want to know about direction at the beginning. So I'm going to find this vector, or this angle, excuse me, at the beginning. To do that, I'm going to use the other most common formula for solving triangles, and that's the sine law. Remember that the sine law is sine A over A equals sine B over B. So you take pairs, angles that you want, and their opposite sides. And you'll need to compare unknowns to knowns. In this particular example, our unknown is right here. So I'm going to write that down first. Sine theta. Say sine theta over its opposite side. So its opposite side is this side, which is 15. And I need to compare it to an angle and a side that I know. Well, the angle I know is 120, and I just did some math to figure out C, so I'll compare it to angles, or side C. So it would be sine 120 divided by side C. Well, that's where this comes in. Now, don't put in 21.8. I want you to use the full decimal to be as accurate as possible. Accuracy is going to be important in these questions. So I think your calculator actually reads 21.79449472. Put that in your memory somehow using one of the buttons. I'm going to write 21.8, but I want it to be important to know that you're using just that full decimal to ensure accuracy. And now I'm going to solve for theta. Since it's being divided by 15, I'm going to bring this up to the opposite side and multiply. And it'll be sine theta equals 15 sine 120 all over 21.8. So now I'm going to punch this in my calculator. Sine 15 times sine 20. I might put in the sine 120 first, get an answer, multiply it by 15, divide it by 218. Remember, that's going to get me sine theta, which is some big long decimal. I need to push inverse sine to get the actual theta, which is 36.6 degrees. So now that I've done the math, and I see that I have not only the vector's magnitude, but its direction, I can actually describe it. So C is a vector. So it can be described like this. C is 21.8 units, whatever it is, at an angle of 36.6 degrees to vector A. And like I said, we need the tangent rate 36.6 degrees. We need to know that it's relative to vector A, and you see that happening right here, relative to vector A. So this is the most important type of question. We're going to be solving all sorts of different ones like this. So these are the ones that you need to practice, using the cosine law and the sine law.